Hey everyone, welcome back to the channel. In our last video, we delved into the world of dwarf planets. Those not quite planets, like Pluto and Eris, that are massive enough to pull themselves into a sphere. But what about the even smaller stuff? The objects that aren't big enough to become round and end up with all sorts of lumpy, irregular shapes. Today, we're talking about asteroids and comets. We've touched on them before, but let's really break down what makes them different. It all comes down to where they were born and where they live. Asteroids are the rocky residents of the inner solar system. Think of them as cosmic rubble left over from when the planets formed. The most famous neighborhood for them is the asteroid belt, a vast ring of over 1 million rocky bodies, orbiting between Mars and Jupiter. They tend to have fairly predictable, almost circular orbits, just like the planets. They're part of the local family, sticking relatively close to the sun. Comets, on the other hand, are the long-distance travelers of the solar system. They're made of a mix of ice, dust, and rock, earning them the nickname dirty snowballs. This icy composition is a clue to their origins. They formed way out in the frigid depths of the solar system, far beyond the planets, in places like the Kuiper Belt and maybe even the hypothetical Oort cloud. Unlike the steady-orbiting asteroids, comets live a much more dramatic life. They get knocked around by gravity, which can send them on a wild ride. Their orbits are highly elliptical, meaning they swing in from the darkness, hurtle towards the inner solar system, slingshot dramatically around the sun, and then zoom back out into deep space, sometimes traveling tens of thousands of times farther from the sun than Earth is. We've learned a ton about these icy wanderers recently, thanks in large part to the European Space Agency's incredible Rosetta mission. In 2014, it achieved something straight out of science fiction. It landed a probe on a comet. This wasn't just any comet, it was Comet 67P, a fascinating object shaped like a rubber duck. It's actually two smaller bodies, each a few kilometers across, that gently bumped into each other long ago and stuck together. Seeing it up close gave us an unprecedented look at what these objects are really like. But as amazing as Comet 67P is, it's still one of ours, a product of our own solar system. Then, in 2017, everything changed. For the very first time, astronomers spotted an object passing through our cosmic neighborhood that wasn't from around here. It was an interstellar visitor, Te Namaid Eat ʻOumuamua, a Hawaiian word, meaning scout or first distant messenger. It was detected as it was already heading away from the sun, only about 1/5 of the Earth's sun distance away from us. It was small, maybe 1 kilometer long, but incredibly thin, only about 100 meters thick. This bizarre, cigar-like shape and its strange trajectory immediately sparked speculation. Could it be an alien spacecraft? Well, after more observation, the consensus settled on a natural explanation. It had a rocky body, similar to a comet, but there was a key difference. ʻOumuamua had no coma. Not fuzzy, glowing atmosphere that comets from our solar system get, as the sun's heat vaporizes their ice. It was also tumbling chaotically through space, not spinning smoothly like the objects we're used to seeing. The real giveaway, though, was its speed and path. It came into our solar system from high above the plane where the planets orbit, at an incredible velocity. Its trajectory was so extreme that when it whipped around the sun, it picked up even more speed enough to overcome the sun's gravity entirely. It wasn't just passing through, it was escaping. ʻOumuamua was on a one-way trip back to interstellar space. All this evidence led scientists to conclude that ʻOumuamua is a rogue comet, or an exocomet. It's an object that formed in another planetary system, around another star. At some point, gravitational chaos likely ejected it from its home, sending it wandering through the vast emptiness between stars for who knows how long, maybe even billions of years, before its brief, accidental encounter with us. So, where did it come from? We don't know for sure. While we can trace its path back and identify a few stars it might have passed near in the last few million years, the travel time is so immense that it could have originated from almost any star system in the Milky Way. You might think finding an object like ʻOumuamua would be a once-in-a-lifetime discovery, but incredibly, it wasn't. Just 2 years later, In 2019, astronomers spotted another one, T6 Comet. Named Borisov was detected arriving from the direction of the constellation Cassiopeia, also on a trajectory that confirmed it was just visiting. This opens up a whole new chapter in astronomy. What other interstellar messengers are out there? How many pass through our system undetected? It makes you wonder, what if we could spot one on its way in? Imagine sending a probe to intercept it, to land on it just like Rosetta did with 67P. It would be the first time humanity has ever touched an object from another star system. The secrets it could reveal about the universe beyond our own backyard are simply mine. Thanks so much for watching. The universe is full of surprises, and it's exciting to think about what we'll discover next. If you enjoyed this journey into deep space, be sure to hit that like button and subscribe for more cosmic adventures. See you in the next one.